Hi everyone, welcome to GradeUp. My name is Hemant Parhar and today we will be learning about network security. So in network security we will be learning two important algorithms. One is RSA and another one is Delphi-Hellman algorithm. So let's get started. So first of all, what is cryptography? What is cryptography? So it is the science and art of transforming messages to make them secure and immune to attack. So whenever you are sending some message to someone, obviously someone can try to get your message and attack on your packet to get whatever you are sending. So we need to prevent that, and that is why we are going to use the cryptography. We are going to encrypt your message such that even they got your message, they will not be able to read it. So that is what we are going to do in cryptography. So we are going to do in two ways. First one is symmetric key cryptography. So in symmetric key cryptography, both sender and receiver will have the same key, and we will see this. This is known as shared key. Okay, so they will both have the same key. And in another one we will see the asymmetric key cryptography. In asymmetric key cryptography, we will have public key and private key. So both receiver will have its own public key, private key, sender will have its own public key and private key. So total 4 key will be there in symmetric key cryptography. Asymmetric key cryptography. Now see, in symmetric key cryptography, what happened? This is Alice and it want to send a message to Bob. So first it will take the message, then it will encrypt the message using secret key, and that secret key will be common to both Alice will know this key and Bob will know this key, and no other will know about this key. If any other will know about this key, then it can know whatever inside your message. So we encrypt it, then it will went to the internet. Through internet it reached to the Bob, and Bob decrypt it using the secret key and get the message. But remember that both these secret key will be same and both will know about it, Alice and Bob. If anyone is also there, then there will be a problem. And also this method, there is one problem: how to send the secret key. So if Alice want to first send the secret key, then any other can read it. If any other one has read it, then obviously this is a problem. So we need to figure out how we can send the secret key effectively and without anybody know about it. So Delphi-Hellman algorithm is very beautiful algorithm that will give both the secret key, the same secret key, and only these two know about this secret key and no one other can know about it. So that's the beauty of Delphi-Hellman, and we will see this. So now we see the public key and private key, how we encrypt it using public key and private key. So both, I tell you that sender will have public key, sender will have public key and private key. Okay, similarly here, public key, its own public key and private key. Now one thing is that private key will be private to yourself, but public key will be visible to everyone. So public key of Alice can be accessed by anyone, and similarly public key of Bob can be accessed by everyone. Okay, but private key will be private to you and nobody else will know about it. So that is the difference. Now this want to say hello Bob, then it is going to encrypt it using Bob public key. It is using Bob public key. As I told you, public key will be visible to everyone. Everyone knows about public key, but private key, only those person know about private key whose key is that. So if Alice know its own private key, similarly Bob knows in its own private key, but public key will be visible to everyone. Now to encrypt this message, it is using Bob public key. Why not using Bob private key? Why not Alice use Bob private key? Because we can't have access to private key. Okay, then why can't use your private key? We want to do encryption. So what actually we want to do? We want to send our message such that Bob is going to open only Bob is going to open. So if you encrypt some message using public key of Bob, then Bob can use its private key to open that message. Okay, the same, if we encrypt it using private key, then the public key of that person is going to open it. Okay, so we are using Bob public key because we have access to the Bob public key. We encrypt the message, it goes through the internet, and now Bob has its own private key. Using this private key, it decrypts it and Bob get the message, hello Bob. Now Bob will send it. So you must understand that how we are going to do the encryption. We are going to use Bob public key. Okay, and why? When I am using Bob public key, it means that it is going to be opened by only Bob private key. No one other can open it. That is why we are going to use Bob public key. Now we wanted to authentication as well as encryption. So what is authentication? We understood that encryption we want to encrypt it so that only the receiver is going to open. And in authentication, I want to know that this packet is from Alice. Bob want to know that this packet is from Alice. So how it is going to happen? Think about it. I will give you a hint. When Alice is going to signature the message using its private key, which is accessed by him only, then if it is done by using its private, Alice do it signature the message using its private key, then Bob what is going to do? Bob use Alice public key and verify that it is from Alice, and Bob public key will be visible to everyone. Okay, so see here, this is the data we first encrypted, and this we got the encrypted data. Hash will be the encrypted data. Now we use whose key? Signer private key. That is important. We are using signer private key to signature the message. Now using signature algorithm, we signature it, along with that we send the data and it will get to the verifier or receiver. Now receiver will first apply the hash function, check whether it is the appropriate. Using, if I am applying the hash function, that means it is completely encrypted packet and I will get it here. And similarly I apply the verification algorithm using signer public key, and I have access to the public key of signer. Okay, so that is important. So here I am using signer private key and here I am using signer public key for authentication. Okay, so understand this. This is very important when we are for encryption what we are doing and authentication what we are doing. Now we will be seeing Fermat theorem. So Fermat theorem is used to find the remainder. It is very useful if you know it. So see here, if p is a prime number and a is a positive integer less than p. So p is a prime number and a is some positive integer which is less than p. So this is going to be hold. A power p minus 1 is mod equivalent to 1 mod p. So when you divide a p minus 1 and you want it to, when you divide it with p and you wanted to know the remainder, it will be 1. So that is the meaning of this. Okay, so find what will be the remainder of 81 mod 5. 81 mod 5. So we have to do 81 mod 5. Now how can I write 81? I can write 81 as 3 divided by 5. Now if you see that it is like the same, a which is a is equal to 3 and p is a prime number, 5 is a prime number, and we have here p minus 1. So remainder is gonna be 1. Okay, so Fermat theorem is very useful to find the remainder. And this is phi of n. What it signifies is, I am going to use this phi of n. Sometimes it is called as Euler quotient, and it is the number of positive integer less than n which are relatively prime to n. Okay, for example, I want to find phi of 7. So I need to get all those positive integer which are less than 7 and which are relatively prime to n, means their common difference is 1. So 1 is there, 2 is there, 3 also there, 4 also there, 5 also there, 6 also there. And if you take 4, then 1 will be there, 2 is not there, because 2 and 4 have one element common, that is 2 itself. 3 will be there. So only for 4 we have 2, but for 7 we have this 6 number. So if you see, this was a prime number. So for any prime number, phi of p will be p minus 1, because it is a prime number. It is divisible by itself and 1 only. Okay, that is why the number of, if it is p is a prime number, then number of positive integer which less than p and relatively prime to p will be p minus 1. So remember that, because in RSA algorithm we are going to use it. Now we will be seeing RSA algorithm, and almost many times question has been asked from this algorithm, so pay attention here. It is used to generate pair of public key and private key. So for a person, for a sender, it is going to generate public key or private key, or for anybody it is going to generate these two pair. And the importance of these two pair are, I told you that if we encrypt it using private key, then we are going to decrypt it using public key. If we are going to encrypt using public key, then we are going to decrypt using private key. So that is the importance of these public and private key. Now see this, first we need to choose two number. In RSA algorithm we need to choose two number, p and q, and then we need to compute n. N will be the multiplication of p and q. Now after that we need to calculate phi of n. So I told you phi of n is what, and here n will be this, p into q. So actually we need to find phi of p into phi of q, and if you see, p and q are prime number, distinct prime number. That is mean phi of p will be p minus 1 and phi of q will be q minus 1. Okay, and I have shown you in the previous slide how it is happening. Now once we get phi of n, you need to choose an integer from 1 to phi of n such that GCD of e and phi of n is equal to 1. So you need to choose an integer e such that this condition, that e should be less than phi n and should be greater than 1, and GCD of e and phi n should be 1. You can pick any one. And this e and n, always remember n, here we are using n. N is p into q. N is not phi of n. N is p into q. So it is be declared as public key. Okay, e comma n. Now the real task in RSA algorithm is this. After we get this public key, we need to determine d, and d will be like this. Here should be 1 also there. So ed, so when we divide the multiplication of e into d, d is a sum integer. When we divide it with phi of n, then what is the remainder should be 1. We have to find some d like this, and if we get it this d, then we got it. So question in GATE exam mainly comes to find that d. They will give you everything. They will give you e, phi of p and q, and they ask you to find d. And if you see that d will be found if we know how to find the remainder very well. Okay. So understand it using an example. Let p be 61 and q be 53. Generally what's happened that we use 32-bit number. Using 32-bit number, it is a very huge number. And why RSA algorithm is so popular? Because it is really hard to decode it. It is really hard to decode it because here n, if you see n will be the multiplication of two prime number, which is this 61 into 53. You will get this number. Now decode this number such that it will be the multiplication of two prime number. It is very tough when it is 32-bit. Even for 2-digit number, it is very tough to get it. We can do brute force to find such number, but it will take a whole lot of time for 32-bit number. Okay, it will take exponential time if we do the brute forcing. Now after we get n, we will calculate phi of n. Phi of n will be p minus 1, which is 61 minus 1 and 53 minus 1. You will get 3120. Now you need to get one e such that it will be in between these. So here we get 17, and this they should also be GCD of 17 and 312 should be 1. Now you get it. Now the task will be this. Now we need to find d such that when you divide it by phi of n, you will get the remainder as 1. So the multiplication of e and d should be 1. So if you do it, you will get d as this 2753. So that will be the private key. So this is an example. Actually I here uses some big value, but try to do it for small value and you will get it. Okay, see other also examples. So this is how it works. So they ask you to find d, and if you remember every step, then even sometime that it is very calculative. So they will not give you too much big calculation, but they will give you some calculation. If you are good to finding the remainder, then you will do it. Now we will be seeing Delphi-Hellman algorithm. So in Delphi algorithm, I told you that it is used to exchange the key. Both sender and receiver will exchange the key and nobody else will know about it. So isn't it beautiful that they are going to know about the key, and actually they are not sending key and no other will get to know about the key. So it is really a beautiful algorithm. Alice and Bob agreed to use prime number p and a base g. That will be known to everyone. So they are going to use prime number p and a base g. Now what Alice is going to do? Alice is going to pick a random number a, and then it is going to send this to Bob. A is equal to g power a mod p. This is what it is going to send to Bob. Now similarly, Bob is going to choose a secret integer b and send this to Alice. Now what it is going to do? Now Alice is going to compute this s is equal to b a mod p. If you see b will be this, which is sent by Bob. So if you put the b here, you will get it as g b mod p की power a mod p. And if you do the further calculation, this mod p and here mod p, it will be common, so it will come out to be g a b mod p. So this will be the secret key. And similarly, if you do it here, you will get the same. This secret key that Bob compute, you will get the same. So remember that what will be the secret key in Delphi-Hellman algorithm? G, it will be g into a and b, g power a b, and then we have to take the mod with p. So the secret number a and Alice and Bob are choosing, that will be the power of g. So that is why if anyone anyone don't know what the number they have secretly chosen, a and b, no one knows. So that is why only Alice and Bob will get to know about this key. We will try to understand it using an example. Suppose p is equal to 53, g is equal to 5, and everyone know about p and g. Everyone know about p and g. Now a is going to choose a number secretly, and similarly Bob is going to choose it. So Alice has chosen 6 and Bob has chosen 15. Now what Alice is going to do? G power a, this is g power a mod p, and that will be sent to Bob. And similarly, this will be g power b mod p, and this will be whatever the remainder get, we are going to send it to Alice. Now this is what? This is b. This is b, and this is what Bob is going to compute a. So we know that b will be this, and it is again using c, it's a. So it is g b mod p power a mod p. So that, and if you compute it, it will come out to be this. So this will be the secret key. So I have not done the calculation here, like here I just write it down. If you do verify the calculation once and then you go ahead. Okay, so for this I will do it. Okay, so here it is 5 power 6 mod 23, and we need to find the remainder. So how to do it? How will you do it? So there are various, we learned about the trick in aptitude, how to find the remainder. I am going to use one here, 5 to power 3 upon 23. So it will be 25. And when I divide 25 with 3, what remainder we get? 2. And how many times it is? Power 3. So 2 into 2. So 8 will be the remainder. Okay. So learn somewhere how to find the remainder. and because it will be useful for you aptitude purpose also. So learn it, and it is very interesting also. You will enjoy to learn how to find the remainder, and you will surprise that how it is get shortened like this way. Okay, so similarly try to do for this calculation. If you will do the same thing here, 19 power 6 mod 23, then how can I represent 19? I can represent 19 as 25. I can represent 19 as like 25 minus 6 will be 19. Okay, so if I divided with minus 4 power 6 and 23, so minus 4 into, we have to do it 6 times. So minus 4 will be 4 into minus 4, it is going to be 16, and so 16, we get it 16. So if I am doing it here 16, I get 16 here, and I need to do it 3 times only. Now we need to find this. So either you multiply it and divide it, you will get it this. So learn the way to find the remainder, because it is really important in this topic to know how to find the remainder. Okay, so you can also calculate for this calculation as well as this calculation, and check it that the shared key is coming to be 2 only. Okay, so one important thing to be remember here is that what will be the shared key? G, A, B mod P. And what is A and B? A and B are the two number that they have chosen secretly. Alice and Bob have chosen secretly, and G and P will be known to everyone. Remember this, G power A B mod P. It is useful if you remember it. So till now, whatever we have learned about flow control, access control, error control method. We have seen IPv4, IPv6, transport layer, and network security and application. Now I am going to tell you the important topics. So what are really important, you should focus more. So if you see all the top flow control method, all of them are very important, and they have asked a lot of questions from these method. And in access control methods, CSMA CD is really important because Ethernet is going to use it, and every year, almost every year, they asked one question from this topic. Okay, so this CSMA CD is really important. And error control method, CRC, that is very easy. So don't leave it, do it and understand it properly. If you are not able to understand any concept, the best thing to learn it is book. Because in book it will also teach you in somewhat the way that you will not going to forget it for a long time. You just need to apply those concept for few times. After that it will be with you for many times. Okay, so if you are feel uncomfortable with any concept, go read the books. And for computer network, Forozen is very good book. Its language is very simple, so read it. And we have IPv4, IPv6. These are really important, and IPv6 is newly added. So when IPv6 is newly added, it is expected that it is added so that they are going to ask question about it. That is why it is really important, IPv6. You must know every field in their header. Don't remember it, but you must know that what field is going to do what. Transport layer, TCP control protocol is very important, and conjunction control. So they asked question a lot from this conjunction control and TCP. And RSA, from RSA they asked question very frequently, so don't leave. And among the network layer, application layer protocol, they from theoretical question. They will ask you about the port number, and sometimes there are some good question. So in application layer there are 5 protocol that we have seen that are enough. They are not going to ask too much in application layer. So these are important topic. So you must give time to network layer, because network layer is very big and it is almost the 60% of whole computer network, and they really ask 60% question from network layer. Okay, so focus on network layer, it is very important, and read the book. You will feel very confident because you will be very familiar to the language, and in GATE examination the language they are going to use, it is obviously from equal to the level of the standard book. So that's all for today. Keep practicing. make your concept clear, because that is what is required in GATE examination. You must be clear with your concept. Okay, thank you.